Welcome, AP Calculus, to our next lesson. This is section 2.3, part 2. So let me just write part 2 here. So in this next limit lesson, we're going to be looking at limits involving trig. So part 2. So limits involving trig. We talked about limits in our previous lesson. We looked at limits numerically. We looked at limits graphically. We had these different tools for evaluating limits, such as plug and chug, plug and chug, rationalization, factoring, simplifying. And so now in this lesson, we're going to look at limits, but with trigonometry. So in our first example, you have a limit of sine x over x as x approaches 0. You saw this in our lesson previously when we looked at limits numerically. We looked at limits with a table, and you should have determined what the answer was. But graphically, sometimes it's nice to just see this limit problem graphically. So I'm gonna share my screen so you guys could see what we're looking at graphically. So with the TI-84, we're gonna type in the y equals the sine x divided by x function. So to do that, the sine x is right, 2 buttons above the 7, there's sine, then you click the x, you close the parentheses, then you press divided by x. Now sometimes this could get confusing in terms of the fraction notation. So another way to do the fraction is to type in alpha f1. And you see number 1 is numerator over denominator. So you could either press number 1 or press enter. There's your fraction. So again, it's sine x. You close the parentheses, go down to the bottom over x. Press enter. So that's the function that we're going to draw. So now we're going to graph it. So let's go ahead and press graph. And you see our graph right there. That's a sine x over x graph. That's the function y1. Now I'm going to zoom in just a little bit so you could see what happens as we get close to 0. That's the question. That's the limit question. What happens as you get close to 0, as x approaches 0? So let me go to zoom. And that's this button right here. And I'm just going to zoom in, number 2. And I'll press enter. So that allows us to go closer into the graph. Notice how this value right here is 1 and this value right here is 2. And as the blue line gets closer and closer and closer to 0 from the right side, we're approaching this value. From the left side, as you get close to 0, you're also approaching that same value. The question is, what is this value? Now, let's see. I'm gonna, on the TI-84, I'm gonna press trace. See if this works. Okay, there we go. So you can see the y value as you get, so now we're gonna get closer to 0. As you get close to 0, we're at 0.9, 0.93, 0.95, 0.96, 0.97. And take a guess, what do you think we are approaching? What y value are we approaching? And the y value should be 1. Now there's no y value there, and we'll talk about that in a moment. Now from the left side, as you get closer and closer to 0, the x being 0, look at the y value, 0.88, 0.89, 0.90, 91, 92, 93. We're getting closer to a y value of 1. Again, when you're at 0, there is no value. Why do you think that is? So I'm gonna share my screen again. Go back to the blackboard. So the reason why when you add exactly 0 in the graph, and that has to do with this guy right here. When x is 0, you have an undefined situation. Undefined when x equals 0. You cannot have 0 on the denominator, otherwise the function is undefined. But the question that we're asking is, well, let's get close to 0. What happens when you approach 0 as close to 0 as you can? And you saw on the graph that we got close to 0, and the value that we were approaching is 1. So this is a famous limit that I want you guys to know. This is called limits we love. When there's a perfect match, an x and an x, we call that limits that we love, okay? So let's write that down. Remember that. Recognizing limits we love. All right, so let's go to a different type of problem, or actually let's look at some other examples here. Let's see if you guys get this. Limit of sine happy face over happy face as happy face approaches 0, right? That's the limit we love because there's a match. You saw that graphically what we were approaching, and when there's a match, you become 1. You become 1, and that's a match made in heaven. So those are limits we love, and the answer for that is 1. Okay, so just be careful when you're evaluating these type of limits where the x value that you're approaching is 0. So let me see if I can highlight that for you. Here, this x value is 0. We're approaching that value of 0. If we're approaching a different value, that would be a plug and chug problem. All right, so let's just write that down. Be careful. X approaches 0 is different than x approaching, let's say, another number. And this other number will, be careful, x approaches 0 is different than x approaches another number not equal to 0, because will become a plug and chug problem. So if you get a number besides 0, you'll turn this into a plug and chug problem. Okay, and for a little picture for you guys, so you remember this, we could draw it on the side right here. Let's draw it on the side. You have your y-axis, you have this in your notes, your x-axis, and the graph, the sine graph, let's call this f of x equals sine x over x. So it's sine x over x. The graph is relatively close to the x-axis. It goes up, 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 up to a value of 1. It's not defined at 1, right? Because x can't be 0. And then the graph falls down very close, kind of hugging the x-axis. So that's the graph of sine x over x. Okay, moving on. I think this is what I did to slide this up. Perfect. All right. We're learning technology as we do this remote learning as well. Here we go. Next lesson, next example. Example. Limit of 1 minus cosine x over x as x approaches 0. Now we saw this, no, did we see this one with a previous example? I don't remember, but we're gonna look at it graphically. So let me share my screen again. Go back to our TI 84. We're gonna go back to y equals. We're gonna go down and to a different equation, and we're just gonna type that example. Again, the fraction is alpha f1, could press number 1 or enter, up to you. Press enter this time. There's our fraction. And we're going to graph 1 minus cosine x. So 1 minus cosine x, close that parentheses. On the denom, it's going to be x. Now, I don't want to graph the top function, so I'm going to just de-highlight the equal sign. I don't know if that's a word, de-highlight, but I'm going to take away the equal sign highlight by pressing enter. And so the equal sign is not highlighted. So I'm only going to graph the red, the y2, which is going to graph in red. So here we go. Let's graph that. So that's that graph. That's the 1 minus cosine. That's that guy right there. 1 minus cosine x over x. Now the question is, as x approaches 0, it's funny because this tracer always starts at the origin, but as you get closer and closer to 0, the y value, we're approaching a 0. But exactly at x equals 0, can x be 0? No, right? Because the denominator would be undefined. So that's the big idea here. You're seeing the limit graphically from the left. Trace feature, there it is, trace. From the left side, you're also approaching that same value. As you get close to 0, you're also approaching the y value of 0. So that's the big idea. Let's go back to our blackboard. All right, so we saw in this example that we approached the y value of 0. So that's that example. So now I'm just going to test your knowledge and see what you remember. The limit, let's say, as delta x goes to 0 of sine delta x over delta x. Take a guess. What do you think that is? Do we have a match? Remember, that's limits we love. We're going towards 0, and that's a match made in heaven. The answer is 1. Okay, next example. Limit of sine x over x as x approaches 2. Tricky question because you're seeing a match. However, we're not going to 0. This is not that match made in heaven because you're going to a different number. And so in this example, the answer is sine 2 over 2. It becomes a plug and chug problem. Okay, so keep that in mind. And we're going to put a note right here. Note not equal to 1 because x is not approaching 0. All right. So the big idea, you want to write this down. When you have a limit problem of sine some constant over some constant, well, let's say some variable. Actually, let me, I don't like that letter C because C usually represents a number. I'm going to say U. U over U. As U gets close to 0. So when you have a variable U over another variable U, that's a match made in heaven. And that answer will be 1. That's the big idea. Okay, let's look at another example. The limit of sine 3x over x as x approaches 0. So in this particular problem, you could start by trying plug and chug, but notice when you try plug and chug that, to have my pointer here, you're gonna see all my pointers, some really cool pointers. I'm gonna go with the hand. So when I do plug and chug, you have a 0 on the denominator. That can happen. So we're going to be fancy. We're going to be creative with our math skills. So what we're going to do is, trying to get my marker here. What we're going to do is multiply the top and bottom of that fraction by 3. So we're going to multiply this whole fraction, the numerator, by 3, and the denominator by 3. So we end up having limits of 3 sine 3x over 3x, because x times 3 is 3x, x approaches 0. And now we have a match. This becomes 1. So before I continue getting the answer, just want to point out that this 3 divided by 3 is really 1. 3 divided by 3 is 1. So I'm multiplying by 1. I know I'm multiplying by 3 over 3, but that's 1. And so I'm just changing the look of this fraction. There's that 3 on the numerator. I put a 3 on the denominator, but now it's something that we know how to do. So this is going to become 1. All right, so let's write down the answer. This cancels, becomes a 1. So there's just 3 times 1 in terms of our answer, and so the answer is 3. 3 times this 1 is really 3. So that's our answer in that problem. All right, let's try another example. All right, example. Let's start with the limit of sine x over 3x as x approaches 0. What could we do? What could we do? So what we could do is just think differently. We have a match. If you look carefully, there is sine x over x. That's the match, right? Let me get a different color. So this is the match right here, this part right here. But that 3 on the denominator, we are going to just move it to the side. There's that 3. And so this sine x over x as a limit, as x approaches 0, this becomes 1. So then we're going to multiply 1/3 times 1, and the result is 1/3. That's the answer. All right, next example. Limit of sine 3x over 5x as x approaches 0. So I'm going to give you some clues here. We want to get a match. So what's missing on the denominator to kind of match with the sine function? What's missing is a 3x, right? Because there's a 3x next to the sine. However, you can't just add magically a 3x on the denominator. On the denominator, there wasn't a 3x to begin with on the denominator. So you got to put a 3x on the numerator. 3x divided by 3x is 1. Now we can multiply by 1. We're just being fancy. We're being creative. And our result is the limit as x approaches 0. We have the match. So I have a Cupid arrow with the theme of the heart, right? Of the match made in heaven. So that becomes 1. But we still have 3x over 5x. 3x over 5x. The x's are going to divide out. That becomes 1 as well. And so you just have 3 over 5. So you have 3 over 5 as your answer. All right. I'm going to slide this up so I have a little bit more space. This one's going to be some writing in this next example. Move this up. There you go. So in this next example, we have the limit as x approaches 0 of sine 3x over sine 8x. All right. So we want to have these matches, right? We want to have these matches so we can make these signs become ones. So this is how I'm going to approach it. I know there's a sine 3x on top. To make a match with that, I need to put a 3x on the bottom. But I can't just put a 3x all of a sudden. I have to use my math operations. 3x divided by 3x is 1. That's legal in math. I could do that. So I could multiply a function by 1. That's 3x over 3x. Now there's also an 8x there on the denominator. So if I want to create a match, I need to put an 8x on the numerator. But I can't just magically put an 8x, so I have to multiply by 1. So that's what I end up doing. Next, I could just rearrange these terms. So I'm just gonna move things around. Sine 3x. I'm gonna put the 3x right under it. So I'm dealing with, I'm just gonna circle this sine 3x. I'm putting this 3x right under it. Then I also have a times sine x. And I'm gonna put an 8x right above it. And I still have the 3x times the 8x on the bottom. I have the 8x on the bottom. So now I have these matches. You saw graphically what they will equal to. So this becomes a 1. This 8x over sine 8x also becomes 1 as x approaches 0. You could do that on your graphing calculator. You'll notice that will also become 1. And so we're just left with 3x over 8x. Well, the x's could divide out. And our final answer is just 3 over 8. All right, we got 5 more examples left and we're done with this lesson. It's kind of nice. Moving on. So now we're gonna move into a different example where we use some trig identities. So this is an example where we use trig identities using trig identities. So example, the limit of tan x over x as x approaches 0. So that's the limit of tangent x. I don't like how that tangent came out. It looks like some other crazy writing. So let me just kind of fix this writing for you. And I have all these other little marks that are not disappearing. All right. I guess that's how it is with a whiteboard. In this case, a blackboard. Okay, but let's continue. So we have tangent x. All right. So to handle this type of problem, since let's say you don't have a graphing calculator, the identity for tangent is sine over cosine. So I'm just gonna let you know, I'm gonna work with the identity for tangent. And I end up having limit as x approaches 0, tangent will become sine x over cosine x, and I still have an x on the denominator, right? Now, there is a match, sine x over x, remember that, as x approaches 0, this becomes 1. But we are still left with a cosine on the denom. So you have the limit as x approaches 0 of 1 over cosine x. And at this point, you're going to plug and chug. Plug in 0 for x, and you get cosine of 0. Now, this is where you have to know the values for cosine 0 or cosine pi over 2 or sine of 0. And so I hope that you are okay with your pre-calc skills. If not, you might need to brush up a little. What helps for me is drawing a little picture of the unit circle. And I know that if I'm at 0 degrees, I'm over here. That's 0 degrees, so cosine 0. And I know that cosine represents the x value. And so the x value of the red dot is 1, because this is a unit circle. The radius of the circle is 1. So cosine of 0 is 1. And so my answer is 1 over 1, which is 1. So that's that problem. Moving on to our next example. When I double click the zoom feature, it just makes it small, but I gotta move this up. I'm sniffling, I'm sorry you guys. My allergies are kicking in. It's 2:15 in the morning. I was lesson planning, and aside from lesson planning, I just told myself I gotta make these videos. I gotta make them for AP Calc. So right now it's 2:15, but it's okay. You guys will have your videos Wednesday, ready for Thursday. Well, Wednesday, so you can watch them Wednesday later on today. All right, our next example. The limit as x approaches 0 of secant x over x. That m I don't like. Let's fix that. All right, limit. There you go. So we got to use another trig identity for this type of problem, something that we know, and we can rewrite the secant as 1 over cosine. That's the identity for secant. So secant is the same as 1 over cosine. All right, so let's rewrite this. We have the limit as x approaches 0 of 1 over cosine x times, underneath you have a times x. So we know that the limit as x approaches 0 of 1 over cosine x. Let me kind of just highlight this for you. We know this already because we did it in a previous example. We did it right up here. We know that limit is 1. So if I wanted to, I could write it like this. I could write this as the limit as x approaches 0 of 1 over cosine x times the limit as x approaches 0 of 1 over x. So I know this guy will become 1 times. The question is, what is the limit of 1 over x as x approaches 0? Well, isn't it true the denominator here is going to become 0? And that's bad. That's undefined. So 1 times something that's bad, in this case, undefined, we're going to say the limit does not exist, DNE. So the limit does not exist. My writing is not the best right now. I'm sorry. So you could just say DNE, which means limit does not exist. Limit does not exist. All right, we got 3 more examples. Here we go. Let's do this. Let's go. Let's go. All right. Example, evaluate each limit if it exists. Example, letter A. The limit of x over cosine squared x as x approaches 0. Your next example is the limit of sine squared x over x as x approaches 0. And the last example, letter C, is the limit of sine squared x over x squared as x approaches 0. Okay, so 3 examples. So let's start. In the first problem, letter A, you have x approaching 0, but cosine squared x means you have 2 cosines, right? You have cosine x times cosine x. So now, if x approaches 0, you could do plug and chug. So if we do plug and chug, you have cosine of 0 times cosine of 0. Think about that unit circle. Do you remember what cosine of 0 was? That's 1. Cosine of 0 is 1. So we have 1 over 1 as our answer, which means the answer is 1. That's the result. That's the limit of that function for part A. All right. Letter B. In letter B, you have sine squared x over x. So we could say you have sine x times sine x over x as x approaches 0. So you know there's one of the limits that you love, sine x over x, so that's going to become 1. That disappears. Now we just have sine x. So you just have sine x by itself. As x approaches 0, there's no fraction, so you could do plug and chug. The question is, what is sine of 0? Something that I want to point out is you don't write limit anymore. We're not going to write limit because we did plug and chug. Okay, we did plug and chug, so don't write limit. So we just have to evaluate sine of 0. Go back to the unit circle. And let's see if I could go back there for you guys real quick. There's our unit circle. We are trying to figure out what sine of 0 is. So on the unit circle, let me get my pointer. Let me get my pointer for y'all. Here's my pointer. Okay. So on the unit circle, if we're at 0 degrees and we're trying to find sine of 0, sine represents y value. So what's the y value? What's the y value there when you have 0 degrees? What's sine of 0? What's the y value? And that's 0. The y value is 0. We're not going up. We're not going down. We're right there at 0, at the origin. That's the y value. So let's go back. Yay, that takes me back. So that's what that does. Okay. So sine of 0 is 0. That's the answer, 0. Sine of 0 is 0. Well, the limit is 0. The limit of that problem. So let me say, when you do plug and chug, you're gonna get 0 as your answer. Yeah, so this was correct. I could have just said that. All right, letter C. We have one more problem. So we're gonna say the limit. I'm gonna separate the sine squared into sine x times sine x. There's 2x squared, so I'm gonna write x times x. I'm just gonna separate those terms. And this is a limit you love. This is so easy. You love sine x over x because that's a match. And that's another match made in heaven. So you have a 1 times a 1. 1 times 1 is 1. That's the answer, you guys. All right, so at this point, you guys could do your next homework assignment on 2.3. Thank you guys for checking in. I'm gonna stop my video. Get ready to record the next one for you. Bye, you guys.